Welcome to day 12. Today, we're talking about a really practical technique called sampling. By the end of our short time together, you'll get the intuition behind how to pull powerful insights out of massive data sets without having to process every single byte.
So, let's start with a feeling I'm sure you've had. You finally get your hands on a huge, promising data set. You go to load it into your notebook, and the whole thing just crashes. Out of memory. It's a classic roadblock, but it brings up a really important question. Did you really need all of that data to begin with?
You see, the solution isn't always to get a bigger server or more RAM. The smarter approach is to be more strategic. The whole idea here is that a small, carefully chosen piece of your data can often tell you the entire story.
So here's how we'll break it down. We'll start with why big data can be a problem. Then we'll cover the core idea of a sample. We'll look at the two main ways to pick one, walk through a few key methods, and then see how it all applies to modern AI.
All right, so let's dig into that first part. Why can't we just throw all our data at every problem?
Well, imagine you had to find the average height of every single person in a city of, say, 3 million people. Actually measuring every individual, it would be a total logistical nightmare. The time, the cost, it's just not practical. This is exactly the challenge we face with large data sets.
The problems really stack up pretty quickly. It takes way too much time, it needs a ton of computational power, it costs a fortune to store and process, and sometimes, like with the city example, it's just physically impossible to get everything.
And that brings us to the elegant solution, the art of the sample. It's a simple concept that's incredibly powerful.
The best analogy I've ever heard for this is soup. You know, to see if a big pot of soup is seasoned correctly, you don't have to eat the whole thing. You just taste one spoonful. But that spoonful has to be representative. If you only scoop the salt from the top, you're going to get a very wrong idea about the soup. It's exact same with data. So to put a formal definition on it, data sampling is simply the method of picking a smaller subset of data from a large population so that we can learn something about that entire population.
Now, how we choose that spoonful of data is absolutely critical, and there are really two main ways to think about doing it. On one path, we have probability sampling. Here, every single data point has a fair, known chance of being picked. It's all about randomness, and it's our best bet for getting a sample that truly reflects the whole data set. On the other path is non-probability sampling. This is where we pick data based on what's easy or what we think is right. It can be quicker, sure, but it's also really risky because bias can creep in very easily. For machine learning, we almost always want to stick to probability sampling.
So let's walk through a few of the most common probability methods that you'll actually use.
The most basic one is called simple random sampling, and it's exactly what it sounds like. Think of it like putting every data point's ID into a giant hat and just drawing some out at random. Every single point has an equal chance. This is a great starting point, especially if your data is fairly uniform.
But what if your data isn't uniform? What if it has important subgroups that you need to make sure are represented? Well, that's what stratified sampling is for. The idea is to first divide your data into these subgroups, we call them strata, and then you take a random sample from each one. So, for example, let's say you're sampling your user base, and you know that 70% of your users are on mobile and 30% are on desktop. With stratified sampling, you would make sure your final sample has that exact 70-30 split. This guarantees that you don't accidentally ignore one of your subgroups. It's super useful for dealing with imbalanced data. Now, there's another method called cluster sampling. It seems similar to stratified at first because you're still dividing the population into groups or clusters. But here's the key difference. Instead of sampling a few data points from every group, you randomly select a few entire groups. This is incredibly efficient when your data is naturally grouped, like, say, customers in different cities. Instead of trying to sample a few customers from every single city in the country, you could just randomly pick 10 cities and then include all the customers from those 10 cities. It can be a massive time saver.
Okay, so these are all solid statistical techniques. But why is this so critical for you as someone building machine learning models today? Well, the reasons are extremely practical. Sampling is what makes it possible to train models on datasets that are too big to fit into memory. It's one of our best tools for handling class imbalance, like in fraud detection, where 99% of transactions are normal. And at the end of the day, it saves a ton of time and money, and it's our first step toward building models that are fair and unbiased. And you have to remember, the stakes are pretty high here. If you train a model on a bad, biased sample, the model itself will be biased. It might work great on your test set, but it's going to fail in the real world because its view of the world was skewed from the start. Good sampling is your best defense against that.
Here's a quick, concrete example. A team was building a model to find defects in car brake components. Now, some defects were really common, but others were super rare. By using stratified sampling, they made sure their training data had enough examples of all the defect types, even the rare ones. The results? A model that was 95.6% accurate and could reliably spot every kind of fault. So, to wrap it all up into one sentence, sampling is the strategic process of selecting a small representative data set to efficiently uncover insights about a much larger one. And if there's one thing to take away from this, it's this. Your model is only as good as your data. And using the right sampling technique is how you ensure your data is good right from the start.